Hey, hi guys. I hope you all had a really nice Christmas. And it's good to have you all back and ready to start the new year. Already halfway through January, which is crazy. Today we're going to be covering algebra, looking in particular at the following things. So algebra basics, we'll go over kind of the general rules behind algebra, and that will help us for the rest of the morning. Powers and roots, surds, factorizing. We'll also factorize quadratics and more complex quadratics. And then we're going to have a look at solving equations and rearranging formulas at the end. As always, this class is recorded, so you'll get the recording. You'll also get the PowerPoint and the and a set of questions as well for each of these topics with answers. So if you're not sure on anything today, have a rewatch of the video and hopefully it will make sense. If you've got any questions in the meantime, pop them in the chat like normal, or if you, I'm not sure you guys can turn your microphones on, but if you want to ask a question, I can turn your microphone on for you. We're not going to do Kahoot today, and I'll point you towards some tips if I can. So how the session's going to work then is we are going to spend the first 45 minutes looking at algebra basics, powers and roots. They're probably the easier topics to look at first, and then we'll have a break in about 45 minutes, move on to surds, and we're going to finish at 2 o'clock today, and lunch will be at 12 o'clock. Okay, cool. So let's start then with the general rules. Now, we'll first look at multiplying because multiplying is definitely the easiest one to look at. Now, when we are multiplying, the main thing to think about in algebra is that we don't have that multiply sign. So for this first one, A times B, it becomes a, oh, why won't it let me draw? Becomes, oh, hang on a second. Okay, we're struggling to write today. Why are we not drawing? Hang on a second. Let me try again. Yeah, this is really not letting me draw anything. Can you guys see the main slide that I'm looking at, the general rules of multiplying? Yeah. Okay. Why it's not letting me draw anything? You're not letting me do anything at all. This is weird. Right, I'm just going to leave the call and then do it again, and we'll see if that works. So give me 2 seconds. Sorry, guys. Oh, I can't leave. Right, we're going to stop sharing and I'm going to try and share it again. Okay, I really don't know. Right, it's working now. I just had a little moment. Okay, right, let's continue. Okay, so if we're multiplying A and B together, we're just going to write that as AB, which I'm sure you're all fairly happy with. The same with if we're doing 5 times C, that's going to become 5C. So we're essentially just removing this multiplying sign. So 6 times A times B is going to become 6AB. And then if we've got B times B times B, This one's slightly different. If we have two things that are multiplying together, that are the same number, or the same letter, sorry, they are going to become b to the power of 4. If we think about this one, it's like if we had 5 times 5. Now we know 5 times 5 is 25. But we also know that 5 times 5 is the same as 5 squared. So that little power we have in the corner represents how many 5s we've multiplied together. So if we had 4 times 4 times 4, we have 4 cubed. Ooh. 4 to the power of 3, because we have 1, 2, 3 4s. So that's the same principle down here. We've got 1, 2, 3, 4 b's, so it becomes b to the power of 4. We can only put it to the power if it's the same letter. For the others, we just take away the multiplying sign. Okay? That's kind of the general rules for that. So let's have a look at the next page then. These ones are slightly more complicated, but are still working in very much the same way. So 4a times 5b, we're still going to remove that multiplying sign, but this time we've got two numbers in front of our a and our b. So what we need to do is multiply those together first, and then add those ones on the end. So 4 times 5 is 20, a, b. Is everyone happy with that? I feel like this is just covering a lot of basics, or just kind of the principles behind it for most of you. Now, if we've got 10t times 3t, our 10 and our 3 are going to get multiplied, and our t and our t's are going to get multiplied. So 10 times 3 is 30. And we said if we have two of the same letters being multiplied together, we're going to have t squared. Okay. Our next one then, if we are multiplying something that has a power with something else that's the same letter, we need to add those powers together. If we think about that, let's go back to our 5 times 5. If we have 5 times 5, we know that that's 5 squared. If we have 5 times 5 times 5 times 5, that's 5 to the power of 4, because we've got 4 lots of 5. If we then had 5 squared times 5 to the power of 4, that is the same as having all of those 5s. So 5 squared was 5 times 5. Put that multiplication in between them. And 5 to the power of 4 was 5 times, sorry, my writing's bad on a computer, times 5 times 5. We end up with 6 5s that we're multiplying together. Now, can you see how, if we cheat a little bit, that's the same as doing 2 plus 4. So our general rule that we can use is if we had, you might have seen this before, a to the power of m, so a represents any number and m represents any number, multiplied by a to the power of n, we get a to the power of m plus n. Does that make sense? And now it only works if they are the same letter. We can't add the powers if they're different letters. Okay, so t to the power of 4 times t is going to give us t to the power of 5. because we're imagining there's a little one there. Our last one then, 7a squared times 8a to the power of 4. So we're doing our numbers first, then we're doing our letters, including those. So 7 times 8 is 56. A, how many A's are we going to have? What is our power going to be? It is going to be 2 plus 4, so 6. Does that make sense to everyone? Does anyone have any questions so far? I feel like for you guys, most of it is fairly straightforward. Brilliant. Okay. Cool. Let's move on then. Now I'm going to try and go through all the rules first because I feel like we don't need to spend too much time in between going through some questions. So we're going to go through all the rules first, and then we're going to go over some exam questions for algebra. Okay. Cool. So we've done multiplying. Next on our list is dividing. Now they're kind of, dividing is basically the same as multiplying, but obviously works in a little bit of a different way. Instead of in multiplication where we are adding, so if we had t to the power of 5 times t to the power of 2, because it's a multiplication, because it's multiplication, we add. So we'll have t to the power of 7. Now in dividing is, remember, just the opposite of multiplication. So we are going to take away our powers. So 5 minus 3 is 2. And that is literally it. So if we have, let's write it out with our a to the power of m. So a to the power of m divided by a to the power of n equals a to the power of m minus n. Okay, brilliant. Right, that's the general rule for that. You might also see division kind of written as a fraction as well. Don't be alarmed, that's exactly the same as putting 12a cubed with a divide sign, dividing it by 4a. Now again, this is very similar to our multiplication. We're just, the most important thing to remember is to look at that sign, because if that's a multiplication sign, you're going to do the opposite, aren't you? So we need to look at that really carefully. So firstly, we want to do our numbers. So 12 divided by 4, which is 3. We then want to look at our letters. Now we've got a cubed divided by a to the power of 1. A cubed divided by a to the power of 1. Remember, we need to take away. We're going to have a squared. So 3a squared. Does that make sense to everyone? Or does anyone have any questions? No? Cool. Fantastic. Right, guys. I said we weren't going to do any questions. I'm going to give you these ones as a chance to have a go. So in the chat, can you number them 1, 2, and 3? For the powers, don't worry, you obviously can't put a power in the chat, but just put the number on the end after the letter, and that's fine. I'll know what you mean. Have a go at these 3 questions then, using that rule. So I'll give you a few minutes to have a go at those. Once you're done, pop your answers in the chat. There are about 7, 8 of you, 7 of you. Well done, guys, you're doing well. Fantastic, guys. Yeah, you basically know what you're doing. It's just nice to see some answers so I know, just to make sure you guys understand. Fantastic, yeah. So we'll go through them whilst the rest of you finish off the last few questions. So a cubed divided by a squared, we're going to do 3 take away 2. So it is essentially a to the power of 1, but remember in algebra we don't really write that 1. We can just leave it as a. 3b to the power of 5 divided by b squared. So we're going to do 3 divided by our imaginary 1. So 3 divided by 1 is still 3. B, 5 take away 2 is 3. So b, 3b cubed. Our last one then, we can leave it as a fraction. Does exactly the same thing as if we had a divide sign there. So 18a to the power of 4 divided by 3a. So 18 divided by 3 is 6. A 4 take away 1 is 3. Cool. Well done, guys. You all did really well. If anyone doesn't understand that, pop a message in the chat and I'll go through it again, but I'll assume that you all understand if I don't hear anything. Brilliant. Okay, so that is our dividing. Our next one we're going to look at, so we've looked at multiplication, we've looked at dividing. We're now going to look at collecting like terms. Now that involves adding and subtracting. So it's really important that you look at the adding signs and the subtracting signs. Now, I've put this little picture here because it's showing that each of these coloured circles is a term. Okay, so when I refer to a term, I refer to the collection of that number with the letters that it's associated with, but also the sign in front of it. Okay, 4xy obviously doesn't have a sign in front of it. We assume it's positive. Okay, if there was a negative in front, then it would be negative. If it doesn't have a sign, it's positive. Okay, so that's our first term. The 5x squared has a plus sign in front of it, so that 5x squared is positive. Okay, 2y has a minus sign in front of it, or a take away, a subtract sign. So that is associated with 2y, not associated with 5x squared. Does that make sense? Yeah. Okay. So that's just something to bear in mind when we have a go at some questions. So when we're collecting like terms, obviously if we were multiplying a times a times a, we would end up with, let's write this out. So if we had a times a times a, we would get a cubed. If we are adding, imagine it's like having, so a represents a pencil. So a is, here we go, a nice little pencil, really bad pencil, okay? The rubber on the end. Right, so an A is a pencil. Now, if I've got 3, so 1, 2, 3 of A, that's going to be 3A, yeah? So A plus A plus A is 3A. Now, if we have the same letter here, B and B, that's fine. We can just add the numbers together. It's like saying, okay, if B is a banana, there we go. It's a rubbish banana, but you get the idea. B is a banana. We've got, say Lily has 3 bananas and I have 2 bananas. Together we have 5 bananas. Does that make sense? 5B. Now, the one that catches everyone out is A plus B. If we're doing A times B, that's fine. It doesn't matter. They're the same. They're different letters, but we just get rid of the multiply sign and put them together. But A plus B, we cannot add because they are not like terms. Collecting like terms means collecting terms that are exactly the same to each other, okay? So A and B are different. If we had X, Y, and X as two terms, they are not like terms because one has a Y attached to it and one doesn't. They are not exactly the same. Even though they both have an X, they're not like terms. We can't add them together. X, Y is something different. That's X times Y. Whereas this other one is just X. That's like saying 5 times 2 is the same as 5. No, it's not. 5 times 2 is 10. Okay? So A plus B, we can't do. It just stays as A plus B. Then if we're subtracting, we're doing the same thing. They're both still B, so that's fine. So 7B take away 4B is 3B. Okay. Does anyone have any questions about this page? Does everyone understand what I mean by collecting like terms? Brilliant. Fantastic. Thank you for your messages. Right. Cool. So have a go at these then. So can you simplify 3A plus 5B plus 7A plus 4B? This last one here, or 2 and 3 really, think about what I meant by like terms. Okay, so once you've got your answers, pop them in the chat like last time, and then we'll have a go. So what do I mean by like terms? Yeah, a few of you getting the first one right. Fantastic. The second one, the next two are quite tricky. Just make sure you're looking at that subtracting sign. Work through it separately if you need to. That's how I always do it. Yeah, well done, Essam. Fantastic. Yeah, nice, Simma. Oh, wait, hang on. Double check your number 2. Same with you, Hilal. Double check that one. Double check that one, Lily. Yeah, nice, Asma. Okay, so this first one then most of you got perfectly, which is great. So I'm going to circle our like terms, okay? So firstly, we have 3A plus 7A. That's going to give us 10A. And then 5B, positive 5B, plus 4B is going to give us 9B. So plus 9B. Okay, most of you got that one, which is great. Okay, this second one then, a few of you got stuck on a bit more. Now, our first like terms, 5A and minus 9A. So here we're doing 5A take away 9A. So 5 take away 9 is going to be minus 4. And then obviously our A. So have a look at maybe where you went wrong for that bit. And then our next like terms are minus 3ab and minus ab. So minus 3ab, take away ab. So that's like doing minus 3, take away 1. Now minus 3 take away 1 is going to be minus 4. Does that make sense to everyone? Yeah, that makes sense now. Fantastic, brilliant. Yeah, it's quite, a lot of people get confused when it's already on a minus and then they need to add or take away 1. I don't know why it's more confusing than if you had to take away or add, say, 2 or 3. Try and think of it like on a thermometer almost. So you've got 0 here, and you've got minus 3 down here. If you need to take away 1, you're going down further, aren't you? So it's going to be minus 4. Okay, our last one then. 6c take away 8c is going to be minus 2c. And then 10c squared. So c squared is different to c because c could be 5, but c squared would be 5 times 5, which is 25. 25 and 5 are different to each other. So 10c squared take away 16c squared. So 10, we're doing 10 minus 16. And 10 minus 16 is minus 6c squared. Does that make sense to everyone? Yeah. Yeah, that makes sense now. Fantastic. Brilliant. Okay, I'm going to clear all of that. We're going to have a go at doing some questions then. So I put them all on, but can you have a go, please, at 2B for me? So I'd quite like to get through some questions because I feel like most of it makes sense to you guys. So can you do 2B? Once you've got your answer, pop it in the chat for me. Fantastic. Well done, guys. Yeah, so we are going to have 7x plus 3x is 10x. So it's going to be 10x, sorry, really bad handwriting, minus 5x. 10x minus 5x is 5x. Fantastic. Feel free to have a go at the other ones in your own time. You'll also get a booklet on them anyway. So, and I'm fairly confident you guys can do these ones. I'm going to show you some harder ones anyway, which is where we tend to struggle a bit more. So there are your answers if you need them. Cool. Can you have a go at 7C for me? Well done, Taylor. Yeah, nice, Lily. Yeah, well done, Simab. Cool. So we are going to be doing 3 times 3, which is 9. P times P is P squared. Fantastic. Brilliant. Cool. Okay, and can you please have a go at, let's do, which one should we challenge you with? Let's do 10A. Have a go at 10A. So 2y plus 6y divided by 2. So have a think about what you need to do first. Yeah, well done, Lily. Well done, Simab. Nice, guys. Does anyone else want to put their answers in the chat? Just so I know you understand. If you don't, message me and I'll try and explain. Perfect. Okay, yeah. So we need to make sure we're adding on the top first. So 2y plus 6y is 8y. We're dividing it by 2. So we're going to have 4y. Fantastic. These are exactly the same. So 7 plus 5 is going to be 12x. Divided by 4, we're going to have 3x. Our last one, 10d divided by d. So 10d divided by d. Well, 10 divided by 1 is 10. D divided by d is 1. Because if you have any kind of thing that is divided by itself, remember it's 1. So 10 times 1 essentially, well, that represents our d times d, so it's just going to be 10. Does that make sense? We have a letter divided by itself, it's just 1. Yeah. I'll take that as a yes. Right. Okay, a slightly trickier one for you then. Can you simplify this? Now, go all the way back to year 7 and 8, where you did, some people called it bod maths, some people called it bid maths. Can you remember what we will need to do for this question? So have a go. I'll leave it up to you. Once you've got your answer again, pop it in the chat. I was going to say, so you need a little bit more on the end of that, but looking good so far. So once you've got your answer, pop it in the chat, just so I know most of you are trying to get there. Or if you're not sure, feel free to put not sure, and we'll go through it in a second. Not quite, Lily. Haven't. Oh, should have been an ad. Let me just check again. Double check a couple of those. You're almost there. SM, well done. Hilal, do you want to put any indices in? You're almost right. Almost right again. What needs to go with that E? Have a look. Okay, right, let's go through it then. So if you remember from bod maths, bid maths, brackets, orders, divide, multiply, add, subtract. Yeah, well done, Hilal. Fantastic. Cool. So multiplying comes before adding or subtracting. So we want to multiply those together. We want to multiply those together. and then have a think about the others in a second. So 9e times 2e then. Well, let's have a look. We're going to do the numbers first. Hold on, add them up. 9 times 2 is 18. E times e is e squared, remember? If we're multiplying, we're going to square them. If we were adding, then it would be different and it would just be e still, okay? This is where, now that we've learned multiplying and dividing, even though doing them separately is fine, when we're putting them in one equation, we tend to get a bit confused. Now, our plus is associated with our 3p. So it's going to be positive. 3p times 2p. So we're going to do the numbers first. So 3 times 2 is 6. P times p is p squared. Okay. Then we're just going to add in our other ones at the moment. So minus 2e squared plus 6. Okay, now we want to collect like terms. So we've got, brilliant, fantastic, Lily. So we've got our like terms. So e squared and e squared, they're like terms. P squared, there's no other p squareds in this question, in this equation, and then 6, there's no other numbers without any letters. So let's think about our 18e squared and our minus 2e squared. Remember, the minus is to do with the thing that comes after it. So 18e squared take away 2e squared is going to give us 16e squared. Remember, when we're adding and subtracting, we don't mess with the squares. Okay, and then we can just add the rest on. So plus 6p squared plus 6, and that's our answer. Does that make sense to everyone? Does everyone understand whereabouts they maybe went wrong or got a bit stuck? Yeah. Brilliant. Okay, cool. I'll assume that makes sense to you all. Right, let's finish then with this last one here. So find an expression in terms of x and y for the perimeter of this shape. So this is quite a tricky one. It's number, you can see it's number 17 in our exam paper. So it's going to be, and remember, as you go through a maths paper, it gets harder as you go along. So 17 is quite high up. There's normally about 21, 22 questions. So this is up there with the harder ones. Have a go, see how much you can do. There's a few gaps missing before you can find an expression for the perimeter. Have a think about how you would work out the perimeter of a shape. See if you can come up with an equation. We'll go through it. But this will be the last question before a little break. So have a go at this one. Once you've got your answer, pop it in the chat. Fantastic, Sam, well done, really well done. Super speedy as well. Lily, double check yours. I think you've missed part of one side. It looks like. So I'll check you've used all the sides, so remember what the perimeter is. Not quite. Okay, does anyone else want to put their answer in the chat, or are you unsure? It's quite a tricky question. Just before I go through it, I don't want to ruin you having a go. Okay, let's go through it then. So, when we're thinking about a perimeter is adding up all of the sides. So that's adding up, yeah, nice, Azima. So that's adding up this side, this side, this side, this side, and these two sides. Now, those two sides don't have anything on them. So we know that at the moment, to create our perimeter, it's going to be x. Yeah, nice, Lily. X plus 2x plus 2 plus 4x plus 1. Can you see I'm going around the outside? Plus x. Now we need to know what this side is and what this side is, don't we? Because we need to add those on to be able to get the perimeter. So let's look at this side first. Now this side, imagine if we carried on this line, that length would be the same as this, 2x plus 2. Yeah, that's 2x plus 2. But this little bit here is made up of x. So we know that this length must be 2x plus 2, but we need to take away that bit that's not there, so take away x. And we should get 2x take away x, which is x plus 2. Does that make sense to everyone? Does anyone want me to explain that bit again? No? Okay. So that is going to add on to our, so plus x plus 2. Okay, then for this bit here. So that bit we don't know. We know that the whole thing going this way is 4x minus 1. Yeah? We know that that bit is x. So that must make it 4x plus 1, which is the whole length. We need to take off the x minus x, and that will give us what we want. So 4x take away x is 3x plus 1. Does that make sense to everyone? Yeah? Okay. If it doesn't, please do say. So now we've got all of the sides of our perimeter there. We just need to simplify this really long expression that we have. So it is going to be, let's have a think. So we've got 1x plus 2x, that's 3x, 7x, 8x, 9x, 12x, plus 2, 3, 4, 5, 6, 12x plus 6. Cool. Does that make sense to everyone? If you don't understand, send me a message. What we'll do is we'll stop there for now. You've got a bit of a break. Sorry, we ran over by a minute. So there you go, there's your answer. So we've got a little bit of a break now. We'll start back again at 11 o'clock. We didn't manage to do powers and roots in the first bit, so we'll start with that and then we'll move on to thirds. Okay, so go and grab a break and I'll see you again at 11, guys. Well done. Hey, hi guys. If you want to start coming back onto your screens, we're going to get going with some powers and roots, then move on to some surds. So let's get started. So we've done algebra basics start. We're now going to go on to powers and roots and surds. And lunch will be at 12. So we've got a bit of a longer session just for this bit. So we're going to go over some rules first and then go on to some questions and then some trickier rules. So I'd say there's about 7-ish easy rules and about 3 quite tricky rules to get your head around. So we've done a few of these already when we were looking at algebra. So let's go through those ones first. So a squared multiplied by a7, a to the power of 7 is what? Someone wants to pop it in the chat. Yeah, fantastic, SM. A to the power of 9. 7 plus 2 is 9. Okay, what about b to the power of 8 divided by b to the power of 5? Someone else want to pop that in the chat? What will our answer be for that one? B to the power of 3, fantastic. Cool, now we've done those two. Let's look at this bottom one here. D to the power of 1. Oh, actually, no, we've not done that one yet. Oh, yeah, we have d to the power of 1 times d to the power of 3. What will our answer be for that? Someone pop that in the chat. D to the power of 4, fantastic, Lily, well done. Now, number 3 we've not looked at yet. If we have 2 indices separated by a bracket, all we do is multiply them. Okay, that is literally it. So easy. Okay, so it's going to be C. We're going to do 6 times 3. So it's going to become C to the power of 18. Okay, so when they're next to each other and they're only separated by a bracket, we're going to multiply. Yeah? Cool. Okay. What about number 5 then? So e to the power of 0. Does anyone know what that might be? Anyone have an idea? 1, fantastic. Yeah, so anything to the power of 0 is going to be 1. Sorry, I'm just having a few issues with my screen and getting it up. Okay, so e to the power of 0 is 1. Not e to the power of 1, it will just be 1. Okay, so if I had 5 to the power of 0, it'd be 1. That's literally it. Seems a bit weird, but that's just how it works. Now, oh, sorry, my laptop's being a bit crazy. If we have 1 to the power of anything, so it could be 1 to the power of 5, it could be 1 to the power of 7, it could be 1 to the power of 25. Anything to the power of 1, of anything 1 to the power of something, sorry, is just 1. It stays as 1. Because 1 to the power of 5, that's the same as doing 1 times 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 1. Does that make sense? Does anyone have any questions so far? No? Okay. Right, number 7 then is slightly trickier. If we look at the bottom one first then. So the bottom one is U, it's quite difficult to write, so I'm going to write it, yeah. So it's going to be U over V, brackets, to the power of 5. Now, if that bracket is on the, if that indice, sorry, is on the outside, that indice applies to everything inside it. So that is going to be the same as writing u to the power of 5 divided by v to the power of 5. Does that make sense? Yeah? I hope it does. Okay. Perfect. So if we look at 1 and 3/5, we are still going to apply this. So let me write this better up here. 1 and 3/5 brackets to the power of 3. That's going to be the same as doing 1 and, or if let's write that in a better way. So 1 and 3/5 is the same as 8/5. Does that make sense to everyone? Remember we did this ages ago. I think this was our first lesson. Power of 3. Now, if 8/5 to the power of 3, that's the same as doing 8 to the power of 3 divided by 5 to the power of 3, which is a very big number. Something like I think it was 512 over 125. Is everyone happy with that? So if your indice is on the outside of the brackets, apply it to everything inside the brackets. And if we've got two indices separated by a bracket, we're going to multiply them. We're going to go over a lot of questions, so don't worry too much. Okay, brilliant. Right, can you guys then have a go at doing, we've done A and C quite well. Let's have a go at B. So can you simplify 3 to the power of y brackets squared? So once you've got your answer, pop it in the chat. So what is y to the power of 3 squared, or y cubed squared? Fantastic, Eslan. Anyone else want to pop their answers in the chat? Yeah, nice. Oh, Lily, double check. You're close. It's not going to be 3 cubed. It's just the two numbers multiplied together. 3 squared, sorry. So it's 3 squared is 9, but we need to do 3 times 2. So 3 times 2. So our answer is going to be y to the power of 6. Yeah, fantastic. Brilliant. Well done, guys. And we're going to be going over some more questions as well, so don't worry. So they were our easier rules. We're now going to have a look at the trickier rules. So the first tricky rule we're going to have a look at is when we have a negative power. So something like 7 to the power of minus 2. Now, if we have 7 to the power of minus 2, we are going to do something called the reciprocal. Has anyone heard of the reciprocal before? Now, the reciprocal means essentially flip it over and make it positive. Okay? So if we're doing the reciprocal, 7 to the power of minus 2, that's the same as 7 over 1. If we flip that, it's going to become 1 over 7. Our minus 2 becomes a positive 2. And then we can just simplify. 7 squared is 49. Does that make sense? Cool. Okay, so can you guys then try 4? Let's go with an easier number, something nicer. 2 to the power of minus 3. What will that be? And simplify it as well. Brilliant, Aslan, brilliant, Simab. Anyone else? just to make sure you understand. Close, Lily. Remember, we need to flip it upside down. So what does that mean? What do we need? What will it change into? 2 cubed will be 8, but not 2 to the minus 3. So remember, if it's minus, we're first going to flip it. So it's going to be 1 over 2 cubed. And what is 2 cubed? 2 cubed is 8. 1 over 8. A few of you got the 2 cubed a bit mixed up, so make sure you just understanding that. Does that make sense for those of you that weren't too sure? I'll take that as a yes, unless you want to say otherwise. Cool. So that's our first tricky rule. First tricky rule is if you have a negative indice or a negative power, flip it over, make it positive. Yeah? Brilliant. Okay. Second rule then is, well, let's skip that question. Second rule is fractional powers. So if we had something like 25 to the power of a half. This is just something you need to remember, unfortunately, unless you go into more advanced maths and you learn why, but we're not going to for GCSE. So 25 to the power of a half then. A half, if anything's to the power of half, that is the same as it being a square root. So that's the same as the square root of 25. So that's quite easy. It's 5. If something is to the cube root then, so say 64, not cube root, to the power of a third, that is going to be a cube root. So remember, we write that 3 on the outside. We put 64 here. Yeah. Cube root of 64 is 4. Now you can imagine that for something to the power of a quarter, so let's go with 81 to the power of a quarter, that's going to be the 4th root of 81, which you don't necessarily need to know, it's 3. Does that make sense? So if we had something to the power of 5, it would be, we'd find the 5th root of 7, for example. Obviously, we don't need to know that. Does that make sense to everyone? So can you simplify this? A to the power of a half. What will our answer be? Pop it in the chat. Square root of a. Fantastic, isn't it? Exactly. So our answer to a to the power of half is going to be a, the square root of a. Does that make sense to everyone? Does anyone have any questions? No? Okay. The really tricky ones to look out for then are when you have something like 49 to the power of minus a half. Okay, that is quite a tricky one. Let's look at it in terms of a. So if a to the power of a half is root a to the power of minus a half. Remember we said if something is a minus indice, we need to flip it and make it positive. So it's going to become 1 over a to the power of a half. Everyone happy with that? exactly like how we just did for our first tricky one. So over here, where you flip it, we now have just done it with a fraction. And 1 over a to the power of a half is 1 over root a. So we can do that for this question, 49 to the power of minus a half. So that is going to make it 1 over 49 to the power of a half, because we're getting rid of the minus. And that is the same as 1 over the square root of 49, which is 7, or 1 over 7, sorry. Does that make sense to everyone? Take that as a yes. Okay, I'm going to erase this, and I want you to have a go. This is actually quite difficult to erase, at doing this question. So can you have a go at doing, let's have a think, 64 to the power of minus a third? Have a go at working that one out, guys. Once you've got your answer, pop it in the chat. Yeah, fantastic, Eslan. Does anyone else want to pop their answers in? Nice, Simag. Cool. So yeah, we're going to have, because it's some negative indice, regardless of whether it's a fraction or not, firstly, we do have to flip it and make it positive. So it's going to be 1 over 64 to the power of a third. Brilliant, guys. Well done. And that is the same as writing cube root of 64. And the cube root of 64 is 4. So our answer is 1/4. Nice and easy. Brilliant, guys. Well done. If anyone's got any questions about that, pop it in the chat and we can go over it again. But our third tricky rule, which is definitely the trickiest, is two-stage fractional powers. So when we have something like 64 to the power of 5/6, nice and easy. I'm going to write it a bit different. We're going to write it up here because I prefer my writing to it being on a screen. So 64 to the power of 5/6. Now, always split that fraction into a root and a power, okay? What I mean by that is writing that is the same as writing 64 to the power of 1/6, see where I'm coming from in a second, times 5. Does that make sense? Is everybody happy with where I got that from? Brilliant. Okay. Now, 64 to the power of 1/6 times 5. Remember, we used a rule a while ago, which looked a bit like this, and we said we could do. We had a bracket separating our indices. That would mean that they're multiplied together. Is everybody happy with that? Yeah, that is exactly the same as the one before. Then what I mean by splitting it into a root and a power, I'm going to write that down. Split is 1/6. We've done all of this before, we just did it. Is the same as doing the 6th root of 64. Once we've done that, oops, we're going to do it to the power of 5. So the 6th root of 64, I don't expect you to know, but it's 2. But you can use a calculator normally in this. And then we want to do it to the power of 5. 2 to the power of 5 is 32. Does that make sense to everyone? Does anyone have any questions? No. Fantastic. Okay, let me try and give you a question then. So if we have, what can we go with? Okay, 8 to the power of 2/3. So can you have a go at that question then, guys? Well done, Sam. Super quick. So follow the same steps that we just did for 64 to the power of 5/6. And can you have a go for this one? Once you've got your answer, pop it in the chat. Well done, Simab. Cool. Okay, so remember we need to split it up first. Yeah, well done, Lily. So we're going to have 8. We're going to do 1/3. Always make it 1 over whatever the bottom number is, times 2. That's the same as writing 8 to the power of 1/3 squared. That's the same as doing the cube root of 8. We just learned that rule. Squared. Now the cube root of 8 is 2. And we're going to square it. 2 squared is 4. Is everybody happy with that? Yeah, fantastic. Okay, a little tip, a good tip actually, is if you forget how to do it that way, another way of doing it is if I write it like a to the power of m over n, so any kind of fraction on the top, so m is any number and n is any number, that's the same as doing whatever that n is, a, so whether it's like the cube root of a or the 4th root of a to the power of m, that's exactly the same as what we've just done here. So if we had, I don't know, say 16, 3/4, our 4 is our n, so that's going to go here, 16, and then our m is our 3, so that's going to go up here. I remember it as the numerator is the one on top and 3 is up here, whereas 4 is down here. 3 is up here, 4 is down there. Does that make sense? So if you don't want to use this method, oops, you can use this method here. Does that make sense to everyone? We've got quite a lot to cover, so I won't go through it too much. Yeah. Okay, cool. Right, good, because I have some questions for you. So that's just the answers. Can you please have a go then? I'm going to get rid of the ones that I don't want you to do because we've done so much of them. can you have a go, please, at doing, I'm going to get rid of that one as well. So C, D, and then B and C. So this one, this one, this one, and this one. Please have a go at those. C is quite tricky. The second C, sorry, is quite tricky. So yeah, see how you get on. Feel free to use a calculator for the last one. It's tricky. I'm going to use my calculator, so I'm not sure. So once you've got all your answers, pop them in the chat. I do agree they are tricky. We have quite a lot to get through. It's probably the hardest classes we'll have because there's so much to do on algebra. Oh, sorry, it says minus a third. Yeah, that's not very clear, is it? Let's draw that in a bit. That says minus a third. I'll let you try and finish off 2C because that's probably going to be the most helpful for you to learn. Double check D Lily, there's a minus there. Right, okay, let's go through them because we've not got too much time. So for 1C then, remember we said that if there's a bracket separating the two indices, we just need to multiply them. So we're going to do 6 times a half as our indice, which is going to be g to the power of 6 over 2, which is the same as g to the power of 3. 6 divided by 2 is 3. So that's 1c. 1d then. 1d, we just essentially need to work through each of the terms. So we've got 2 times 3, so that's going to be 6. We've got h to the power of 5 multiplied by h to the power of 2. So remember, we add indices when we're multiplying them. So we're going to have h to the power of 7. J, then we've got j to the power of minus 2 multiplied by j to the power of 4. So we're still adding them, but we start off in the negative. So it's going to be minus 2 plus 4. So minus 2 plus 4 is 2. Is everyone happy with that? Yeah? Okay. 2b then is where it starts getting a little bit trickier. Oh, it says without a calculator. That's so mean for the last one. I'll let you do it with a calculator. So 2b, we've got 25 to the power of minus a half. 25 to the power of minus a half. Remember, if anything is to the power of a minus, it gets flipped and that indice becomes positive. So 1 over 25 to the power of a half. Yeah. Then we use our other rule, which says anything to the power of half is a square root. So the square root of 25, which is 5. So our answer is 1/5. Did everyone manage to get that? Yeah? I don't want to go over it and people not understand. Cool. Okay, 2c then is the really tricky one. Now, we've got 27 over 216 to the power of minus a third. Now, before we do anything, because it's to the power of a negative number, we are going to flip it and make that indice positive. Okay, seems a bit weird, right? So 216 over 27, because the bracket's on the outside, because the indice, sorry, is on the outside, it doesn't affect it just yet. So we leave that indice there, but it's now a third instead of minus a third. Is everyone happy with that? Does that make sense? Yes, perfect. So that third applies to both of them, which is why before here, we moved that indice with the number to be on the bottom, but because the bracket's there, it's almost like it doesn't affect it. Okay, then we said if the indice is on the outside of the brackets, it applies to everything inside. So it's going to be 216 to the power of a third and 27 to the power of a third. Cool, okay. Then all we need to do is we know that something to the power of a third is the cube root. So we're finding the cube root of 216 and we're finding the cube root of 27. Now I do think this is very mean to do it without a calculator. If we're finding the cube root of 216, 6, and the cube root of 27 is 3. So look at that, it looks nice and easy. So we've got 6 divided by 3, which is 2. So our answer to the whole of that equation, I guess, 27 over 216 to the power of minus a third, is exactly the same as writing 2, which is nice of them, isn't it? Does that make sense to everyone? Yeah? Okay. Perfect. Right. One last question for you all, and then we're going to have a look at surds. So can you do 6c to the power of 2/3 divided by 3c to the power of 5 over 2? So once you've got your answer, pop it in the chat. So be simple about this one. Those indices, we're dividing indices. What does that mean? Are we going to add those indices? Are we going to subtract them? Are we going to multiply them? What do we want to do with those indices? Think of it as if it was 6c cubed divided by 3c squared. What would it look like then? Yeah, fantastic, Hilar. So we are going to be, Hilar suggested, what we got right, subtracting 2/3 and 5/2. So go back to what we've done before, subtracting fractions. How are we going to work that out? Yes, fantastic, Simab. Find the common denominator. So you need to find the common denominator for those. Work out what they will be, subtract them. And that's it. Yeah, fantastic. So 2/3 take away 5/2 is going to be, we'll make the common denominator 6. So that's going to become 4, 6, take away 15, 6, which will become minus 11/6. So if we look at our equation, we've got 6c divided by 3c. So that's going to be 2c to the power of minus 11/6. That's our answer. Does that make sense to everyone? We don't need to worry about doing roots or anything like that. It's literally as simple as subtracting. Brilliant. Okay, right, that is all of powers and roots. I know we've covered it so quickly and we've not really had a chance to go through it much, but if you get a bit stuck, we've gone through all the different rules you could get. So if you need to watch the video back at any point, you can do. And it will, there's always questions on it. A website like Maths Genie is really good. If I pop that in the chat, I'm sure many of you have heard of it before. Maths Genie and Maths Made Easy are really good for like topic specific questions. So there'll be loads on indices and powers that you can have a go at, and we'll also send you loads of questions on it as well. But moving swiftly on, we're going to start with surds. We'll probably continue with it after lunch because we spent a bit longer on powers and roots. So we're going to go through all the rules first and then look at rationalizing. So rule number 1 then is the easiest one. If we've got two things being multiplied by each other, it's exactly the same as algebra. They fall under the same roof, A, B. For example, if we had root 5 times root 2, that would be root 10. Simple as that. Everything just stays as a root, as a surd. Okay? Rule number 2 then is going to be root A divided by root B. That's literally just what it is. If we had root 8 divided by root 2, that would be root 4. Leave that one as root 4, or root 4 is the same as writing 2. Is everyone happy with that? Cool. Now, third one then. Like in algebra, we cannot add together different like terms. So root A plus root B is not root A plus B. It doesn't exist, okay? It's literally just left as root A plus root B. It would be like if we had root 3 plus root 2. That does not become root 6. I'll show you another example to prove that. If we have root 4 plus root 9, that is not going to be root 13. Why not? Because root 4 is 2, the square root of 4 is 2, the square root of 9 is 3, that equals 5. Root 13 does not equal 5. Does that make sense? I just saw your message. Simab, does number 2 stay the same? No, if you can divide it, divide it. So if we have root 15 over root 5, that will be root 3. You leave the root there, but you can work that out. But if it was like root 7 over root 2, you can just leave it like that. Does that make sense? That's like normal fractions. So it's just a root there instead. Yeah, perfect. With this third one though, we can't add them, remember, and we can't subtract them either, because I've proved it here. We've got a root 4, square root of 4 plus the square root of 9. We can't write the square root of 13 because root 4 is 2, root 9 is 3, 2 plus 3 is 5. 5 is not the same as the square root of 13. It would have to be the square root of 25. So that just doesn't work. We can't add or subtract roots. Okay. Number 4, we're going to come on to in a second. So ignore that. Number 5, we're also going to come on to in a second. So ignore that too. Don't worry about those ones at all. Number 6, we are also going to come on to because that's our rationalizing. I'll just put ration. Number 7, our last one that we're mostly interested in at the moment, root A times root A. When something is multiplied by itself, we get rid of that root. It just is A. If I have root 5 times root 5, that's just 5. Because root 5 times root 5 is root 25. We know that from doing our rule here. And root 25, square root of 25 is 5. We have root 8 times root 8, that's just going to be 8. Does that make sense? That's going to be really key when we look at expanding brackets. Yeah. Cool. Okay. Let's have a go at some questions then. So have a go at number 1 for me. And well, yeah, have a go at all of them. We'll go through number 2 and 4. They look a little bit different. Oh, how did you manage to get the root sign, Hilal? If you're not sure how to do the root sign, just put like a /. That's what I always do. Cool. So our first one then is root 33. Fantastic. Well done, guys. the second one.
I found this on the web.
Oh, sorry. The second one, we need to multiply the numbers first. So 4 times 3, which is 12. And then the roots. So 5 times 2 is 10. That's the answer to our second one. So use that to be able to do number 4. Let's have a go at number 3 and 4 for me. Yeah, well done. Number 3, fantastic, guys. Root 30 divided by root 6 is going to be root 5. How about the last one? Yeah, great, Azmat. Have a think about what that root 4 is the same as. What's the square root of 4? And what will it simplify to? Lily, double check yours. Hilal, double check yours. What's the square root of 4? Not quite, SM. Yeah, well done, Lily. What's the square root of 4? Yeah. So, yeah, fantastic. Most of you got that in there. So, we're first going to do 8 divided by 2, which is 4. We're then going to do root 12 divided by root 3, which is 4. Now, that's the same as saying 4 times root 4. Yeah? Square root of 4, remember, is 2. We know that. 4 times 2 is 8. Fantastic, guys. Well done for those of you that got it. Well done, this done. Lily, do you understand? Yeah, you pretty much. Yeah, I see your messages. Cool. Well done, guys. Fantastic. If anyone's not sure, just say. But I feel like it makes sense to most of you. Cool. So when we're going to think about simplifying surds now. Now, when we simplify surds, we are thinking about what 2 numbers will make that root. So if we look at 12, we need 2 numbers that make 12. However, one of them has to be a square number, like 4, 9, 16, so on. Does that make sense? So root 12 can be made up of root 12 times root 1.
I found this on the web.
Sorry, guys, my watch keeps buzzing up. Root 12 times root 1. Root 12 is also made up of root 6 times root 2. It also could be made of root 4 times root 3. But we can only use the pair where one of them has a square root, where one of them is a square number, which is this one. So we're going to have to use this one. So root 12 equals root 4 times root 3. Now, the reason we use a square number for one of them is because to simplify it, this needs to be dealt with. So we're going to have 2 times root 3.
I don't know what you mean.
Sorry, guys. And that answer will be 2 root 3. Does that make sense? Brilliant. Cool. Okay, do you guys want to have a go at the second one then? And we'll go through the third one together. So what is 50 made of? Make sure you pick 2 numbers where one of them is definitely a square number. Yeah, well done, Asma. Really quick. Well done. Well done, Lily. Close, Aslam, with the third one. Second one's right. Well done, Simab. Yeah, if you want to have a go at the third one, have a go at it. I'll go through the second one. So second one then, we are going to use the numbers root 25 and root 2. So the square root of 25 is 5. So it's going to be 5 root 2. The third one then, we need to think about how we can simplify 45. So 45 can be made up of 9, root 9, and root 5. This is where you were really close. Who was it? SM. And root 5. So remember, we need to find the square root of 9, which is 3 root 5. But remember, we need to think about this 3 as well. Oh wait, you were right. I'm so sorry. I was completely misreading that. You are in fact correct. 3, we need to multiply it still by our 3 root 5. And that will get us 9 root 5. Brilliant, guys. Does that make sense, the last one? Sorry, Esther. Yeah, brilliant. Lily's very good at saying yes. Does anyone else have any qualms about this particular area of surds? No? Brilliant. Okay, perfect. We're going to do, I know we've got lunch at 12. We've not got too much time to go over surds. What we're going to do now is starting to look at expanding our brackets of our surds. And then after lunch, we'll move on to looking at the rationalizing the denominator. And then some exam questions, and then we'll move on to factorizing. Okay, cool. So quickly before lunch then, let's have a look at how we are going to expand and simplify these brackets. Fairly straightforward. I'm sure all of you know how to expand brackets, but just in case you don't, there's 2 different ways you can do it. You can either draw your smile, do all of your ways like this, which I find too confusing, or you can use FOIL. So firsties, outies, innies, lasties. That's how I prefer to use it. So firsties. Our firsties then are going to be root 2 times root 2. Can anyone remember what we need to do if we have 2 of the same surds multiplied together? What will that equal? Well done, Neslam. Anyone else? Anyone else know what root 2 times root 2 is? Well done, Nazimat. So root 2 times root 2, remember, is just going to be 2. Because root 2 times root 2 is root 4, and we know that the square root of 4 is 2. So that's our firsties. Our outies then, I've really not made this very clear, have I? Let's start this again. So our firsties were root 2 times root 2. Which is 2. Our outies then are root 2 times minus 3. Remember, the minus 3 applies to the thing after it. So root 2 times minus 3. So that's going to be minus 3 root 2 is how we will write it. Our next one is innies. So positive 4 multiplied by root 2. So 4 times root 2, which is going to be 4 root 2. And then our lasties are positive 4 multiplied by minus 3. So 4 times minus 3, which equals minus 12. Then we just need to put it all together like how we do when we normally expand brackets. So we're going to have 2 minus 3 root 2 plus 4 root 2 minus 12. And then we just need to simplify. So we can do 2 take away 12, which is minus 10. We then need to do minus 3 root 2 plus 4 root 2. So we almost imagine the root 2's, or whatever that root is, being like an x. So it's kind of like saying minus 3x plus 4x. It works in exactly the same way. So minus 3 plus 4 is 1. But obviously we can't have 1x. So we just say x, don't we? So we're just going to say root 2. Does that make sense to everyone? Does anyone understand how we got the root 2? Yes, brilliant. Anyone else not understand? Cool, I'll take that as a yes. Right then, you have 3 minutes to have a go at this question. So once you've done this question, pop your answer in the chat. I'll check that it's right and then you can go for lunch. So as soon as you've done it, you can go for lunch. So I'm going to be checking you've all put your answers in. So once you've done this question, pop your answer in the chat. And then you can head off. Well done, Aslan. Well done, Lily. You can both go off for lunch. Still waiting for 5 of you. Oh, those of you who've gone off for lunch back at 12:30. Cool. Right, we'll go through it. So, did you mean 11, Hilal? I think you did, but almost. So 2 times 3 is 6. That's our firsties. Outies. 2 times root 5. Innies. 3 times root 5. Lasties. Root 5 times root 5 is 5. So 6 plus 5 is 11. 2 root 5 plus 3 root 5 is 5 root 5. And that is our answer. So well done, guys. If you want to head back here for 12:30, if you have any more questions, stick around. And if not, I will see you after lunch at 12:30. Well done, guys. There we go. Cool. Okay, so we need to get rid of the surd on the bottom, multiply the top and the bottom by that surd, and it will remove our surd for us. And we can simplify and we get 3√2. Brilliant. If that makes sense, then can you guys have a go at this question here? So can you rationalize the denominator? So can you get rid of that surd on the bottom? Yes, fantastic, SM. Does anyone else want to have a go at answering? I just want to make sure you are up to date with this bit and whether this is something that you feel okay with doing. Yeah? Does anyone not feel okay with this? Okay, so we are going to be multiplying the top and the bottom by the same thing. So 12 times √3 on the top and √3 times √3 on the bottom. And when we do that, we're going to get 12√3 over 3. Because when we multiply two roots together, we get not a root. 12 divided by 3 is 4 √3. Does that make sense, everyone? Please give me something so I know that you guys understand. Yeah, fantastic, SM. Yeah, your answer was completely right, so well done. Is everyone else there? Can you just let me know that you're there, please? Looks like it might just be you and me, SM. Can somebody just say hi? Hello, cool, thank you. Was everyone else there? Okay, I only have 2 of you then. Right, never mind. Okay, let's carry on because it's late. Right, cool. Okay, now we just had one where we needed to work out, rationalize it when there was just one thing on the bottom, so just the surd. This time we've got one where there is a surd but also another number, so our 2 plus √5. Now, when we rationalize this, instead of just multiplying it by √5, we have to multiply it by the whole thing on the bottom, but in the negative form. So instead of multiplying it by 2 plus √5, we're going to multiply everything by 2 minus √5. I'll show you why in a second. 2 minus root 5. I'm actually going to move that over here. And that is going to be over 2 plus root 5 to minus root 5. Okay, because when we work it out on the top, that's the easiest bit. 6 times 2 is 12 minus 6 root 5. On the bottom, we've got a bit of expanding going on. So this is what we learned just before lunch. So we're going to do our firsties, outies, innies, lasties. So our firsties, 2 times 2 is 4. Outies is minus 2 root 5. Innies is plus 2 root 5. And lasties, we've got a positive and a negative. So it's going to end up being a negative, -5. Okay? When we then simplify it, we're going to have 12 minus 6 root 5 over 4 take away 5 is -1, minus 2 root 5 plus 2 root 5, that's 0. So it's over -1. So we can just put a minus in front of that and a plus because it's been divided by -1, so it becomes a positive. That's our answer. Does that make sense? Do you understand how we managed to get that answer? Yeah, perfect. Brilliant. Now, the reason why we've had to multiply it by the opposite sign is because of something called the difference of 2 squares. And we'll have a look at this in a bit more detail when we look at factorizing. But the difference of 2 squares is essentially where you have the same letter and the same number, but the opposite sign. And what that means is when you then expand it, you end up with having the same positive and the same negative, which cancel out to equal 0. So that's a really good way of getting rid of those extra bits. So getting rid of, in this case, our third. And we'll look at more of difference of 2 squares, but essentially we need to multiply that third by the opposite sign. Okay, so have a go then at this question. So what are we going to need to multiply that bottom by to get our answer? To rationalize. Make sure you're using positive and negative signs correctly. Fantastic, Esther. Does anyone else want to have a go? Cool. Okay, so let's go through it then. So when we're rationalizing, remember we need to do the opposite sign to what it says. So we're going to have 3 and multiply it by root 2 plus 1. And that is going to be divided by root 2, root 2 minus 1, root 2 plus 1. So we're going to simplify it. We're going to expand our brackets. We're going to have 3 root 2 plus 3 over, okay, firsties, 2, outies, plus root 2, innies, minus root 2, lasties, minus 1. Okay, then we need to simplify, so we're still going to have 3 root 2 plus 3 on the top, over 2 minus 1 is 1, and we've got plus root 2 minus root 2, that's 0. So it's dividing it by 1, so our answer is 3 root 2 plus 3. Does that make sense to everyone? All very quiet this afternoon. Yeah, I'm assuming it will make sense. Can somebody other than Eslam put and Simab put something in the chat? Okay, well, I'll assume that everyone's fine then. Right. Okay, a few exam questions then. Have a go at these. So root 30 plus root 120. So can you simplify that fully? So think about what multiples make up 120 and what multiples make up 30. And one of them needs to be a square number. So have a go at that. Sorry, my laptop's being a bit crazy. Cool. Okay, so root 30 then is going to be split up into, what could we have? We could have 10 and 3, but that won't really get us anywhere. Nothing really goes into root 30 other than that. So let's leave it as root 30. Root 120, that can be, what could we have? Root 4 and root 20, root 30 even. 4 times 30 is 120. Root 30 plus 2 root 30 equals 3 root 30. Cool. Brilliant. Does that make sense? Yeah. Fantastic. Cool. Perfect. Brilliant. Okay. We're going to skip that one because it's quite easy. This one's slightly trickier. So all measurements on the triangle are in meters. NOP is a right angled triangle. Find the value of x. So looking back, if you can remember when we did Pythagoras' theorem, how that might relate to this question. See if you can work out the value of x squared. So what is the value of x squared? I'll wait till a few of you have popped your answers in the chat and then we'll start. Then we'll go through it. Okay, so once you've got your answer, pop it in the chat, guys. Okay, cool, got a few answers. Right, so we need to think about Pythagoras' theorem because we are working out one side of a right-angled triangle. Now, a right-angled triangle, remember we have a hypotenuse, which is C, and then these can be labeled A and B. Now, our Pythagoras' theorem is A squared equals B squared equals, oops, sorry. What am I doing? A squared equals B squared plus C squared. I've done that all wrong. A squared plus B squared equals C squared. Squared equals C squared. Now, it's our hypotenuse here, C. This can be A, this can be B. Now, we know C already, so that's not going to help us. We don't know B, but we do know A. So we're trying to work out what B squared is. So we need to do B squared equals C squared minus A squared. Does that make sense? Cool. So what's C squared then? C squared equals 2 root 14 squared. So that's going to be 2 squared times root 14 squared. 2 squared is 4, we know that. And if we're squaring something that's square rooted, they kind of just cancel each other out, because if you think about doing the square root of 4 and then squaring it, the square root of 4 is 2, and if you square it, it's 4. So our answer is going to be 14. And 4 times 14 is 56. So we know C squared, sorry, is 56. A squared then is a little bit trickier. We've got 5 plus root 3. Let's move this out of the way. Let's move that up there. 5 squared root 3 times 5 plus root 3. We're squaring them. And then we just need to expand the brackets. So 5 times 5 is 25. Outies, 5 times root 3 is 5 root 3. Innies, 5 root 3. And lasties, plus 3. So that will get us 25 plus 3 is 28. 5 root 3 plus 5 root 3 is plus 10 root 3. Then we need to do 56. So we've got C squared minus A squared now. So c squared is 56. 56 minus 28 is 28. Plus 10. Sorry, minus 10 root 3. Because we need to take away the whole thing. And that's our answer. That's x squared. Does that make sense, everyone? That was a really tricky one. Yeah, I'll assume it makes sense. Cool, fantastic. There are a few more questions on surds to have a go at on the things that will be sent out to you. So have a go at those. And also there are a few more in the PowerPoint that we're not going to go over. Don't worry about it too much. We've covered everything we need to cover. It's just about applying the knowledge to do it. So you all should be fine. You're all pretty good at answering these. Right, okay. The next bit then we're going to move on to is factorizing. Now, factorizing is pretty much, I feel like you're all probably quite good at factorizing. So we won't go over too much of it, and we'll mainly do some questions. The main thing I wanted to go over is when the format is like this, and then I'll show you another format in a second. So this is when a equals 1. Now our a is if there was a 1 in front of here. So when it's just x squared, it's not like 5x squared or 2x squared, it's just x squared. Now when we're working that out, we want to write down these two brackets like this, which I'm sure you've all seen before. Now the aim is to find, we have x squared plus bx plus c. The aim is to find two numbers that multiply to get c. This is where everyone gets confused and can't remember whether it's multiply or add to get to either one of them, and add to make b. Okay, so adding to make b, multiplying to make c. Okay, we just have to make sure that the positive and negative signs are the right way round, and you can check it by expanding the brackets. If we're asked to solve it, we'll go through that in the next question. Okay, brief overview. I'm sure you can all remember. It's just a reminder. So solve x squared minus x minus 12 equals 0. So the first thing we are going to do then is come up with our brackets. So x brackets x brackets 0. So we need two numbers that multiply to make minus 12 and add to make minus 1. Okay, our minus 1 is in front of our x. So two numbers that make minus 12 could be minus 3 and 4, positive 4. It could be 3 and minus 4. It could be 6 and minus 2. It could be minus 6 and 2. It could be 12 and minus 1. Or it could be 1 or minus 12, sorry, and 1. Now, out of all of those different options, one of those pairs has got to add to make minus 1. And in this case, 3 take away 4 is minus 1. So we know we're going to have plus 3 and a minus 4. Now, I'm sure all of you understand that. If you're not sure about that bit, put a message in the chat and we'll go through it again. But this time they are asking us to solve it. So by solving, what they mean is, can we, if our quadratic is like this, that's essentially, if we were to draw this picture, this equation, this one here, it would look like this a little bit. Now, by solving it, what we are trying to do is to find the points where it crosses the x-axis. We'll have another class on this at a later date in a few months, but essentially solving it is by finding those 2 points. And we have to find those 2 points, and it's when y is 0. This is our y-axis. Our y-axis is going to be 0 at these points. Does that make sense? Because it's not gone up or down, it's right in the middle. So it's y equals 0 rather than x equals 0, because x might be 4 out this way, and 4 backwards. Does that make sense? So how are we going to work that out then? Well, we take each of those brackets separately and put them equal to 0. So we are going to have x plus 3 equals 0 and x minus 4 equals 0. And then we just solve it. So take away 3 on both sides, x equals minus 3, or take away, add 4 on each side, x equals 4. And we've solved that equation. We have found the 2 points where where this equation crosses the or the x-axis, sorry. So we've got x equals minus 3 and we've got x equals 4. Does that make sense? Yeah, brilliant, fantastic, cool. Okay, so that's it being solved for x, right? I feel like that all makes sense to you. Now, the problem is more where students tend to struggle is when a is not 1. So when in front of that x there's a number. That is the trickiest bit. And we're going to go through this in quite a logical way, because a lot of people tend to forget how to do this and kind of go through a bit of like almost trial and error, even though it kind of is. But just kind of guess until they get it right, in a sense, which doesn't always work. You do need to then check, which takes a bit longer when you're in an exam. So make sure that it's in that format of x squared plus bx plus c. That's the most important bit. Sometimes some of these some of the equation might be on the other side of the equal sign, so make sure you get it over to the other side before you do anything. Now we're going to write down our brackets. So our brackets, we know one of them is going to be a 3x, and we know one of them is going to be an x. Okay, equals 0. Now we then need to find pairs of numbers that multiply to get c. Okay, we're not thinking about b yet, so things that multiply to get 6. Let's just think about the 6 first. So things that multiply to make 6. So very similar to the one before where we were looking at what multiplied to make, I can't remember what number it was now, 15. This time we're looking at what things multiply to make 6. So things that multiply to make 6 are, let's go for it up here, 1 and 6, 2 and 3. Cool. Now is a little bit of trial and error. So our potential options are, we could have 3x, 1x, 6. So that's if we're using the numbers 1 and 6. We're going to pretend we don't know what the positive and the negative symbols are yet, so adding and subtracting. So if we were to multiply out the outies and the innies, we would get 18x and 1x. Okay, that's if we were to multiply our outies and our innies. Now, if we were to add those together, we would get, so if we were to add them, we would get 19x. If we were to subtract them, we would get 17x. Okay, keep that in mind. Now, That's one possible option. Our next possible option is if we have 3x and we have the 6 here instead, and we have the 1 here. We did it like that, and we multiplied the outies, we'd get 3x, and multiplied the innies, we would get 6x. If we were to add those, we'd get 9x, and if we were to subtract them, we'd get 3x. You kind of seeing where I'm going with this? Hopefully you are. Okay, so there are 2 options for 6 and 1. We then need to think about 2 and 3. So if 2's here, actually let's start with 3, so I can show you more. And 2 is here. If we multiply our outies, we get 6x. If we multiply our innies, we get 3x. If we add our outies, or if we add those 2 together, we get 9x. If we subtract them, we get 3x. Now, last one. If we had it the other way around, so 3x, which is another color, we had 3x, 2, and x with a 3 here instead, we would get, multiplying them together, 3 times 3x is 9x, and 2 times x is 2x. If we were to add those, we'd get 11x. If we were to subtract those, we would get 7x. So we were trying to look for which one gives us the 7x, which is this one. So we know we're going to have 3x something 2 brackets 3 something x something 3, sorry. So we just need to make sure that we're going to have a positive 7x and a negative 3x. So we can just put our symbols in, really. So if we want to get 7x, we know we need to do 9 take away 2, don't we? So to make our 9, that has to be a positive because 3 times 3x is 9x, and that has to be a negative because minus 2 times x is minus 2x. Does that make sense? Is everyone with me? Perfect. Okay. And then we can solve. So just put it equal to 0 and then rearrange it. Brilliant. Okay, we're going to have another go. Or you guys can have a go using this little step-by-step guide. So can you solve 2x squared minus 9x minus 5x equals 0? Can you have a go at doing that one? So when you've got your answer, pop it in the chat. Do put the brackets in first when you factorized it. And if you can solve it, pop your answers in for when you've solved it as well. Once you've done it, pop your answers in the chat. Okay, cool. So we first need to think about what pairs will make, yes, fantastic, Eslam, well done. So we need to think about what pairs will make 5. Now there's only one option, 5 and 1. So we know that it's either going to be, so we've got our 2x, sorry, what am I doing? X. Now it's going to look like that. It's either going to be 5 and 1 or 1 and 5. Yeah. So if it's 5 and 1, so if we have the 5 there and the 1 there, we are doing our outies, so we'd get 2x, and our innies, we'd get 5x. So if we were to add those together, we would get 7x. If we were to take away those, we'd get minus 3x or 3x. Where's my eraser? Cool. And if we were to do it, if it was 1 and 5, so the other way around, 1 and 5, we would have our outies, so 10x, our innies, which is x. Now if we add them, we'd get 11x. If we subtract them, we get 9x. So subtracting them gives us our 9x. So which way round is our positive and our negative going to be? Our positive is going to be there, our negative is going to be there, because we need to get a +1 and a negative 10x. Does that make sense to everyone? Does anyone have any questions at all? No? Cool. Okay, last little bit then before we carry on with something else. I said I would briefly go over the difference of 2 squared. And quite a few people find this tricky to spot, but once you've spotted it, it's not too bad. So the difference of 2 squares is essentially when you have one thing squared, take away another thing squared. The other thing squared might not look necessarily like it's squared, especially if it's just a number rather than these ones which have a squared next to them. But it's essentially one thing squared, take away another thing squared. Okay? We need to be able to show it factorized and expanded as well. So when it's in its brackets, it's going to be a plus b brackets a minus b. And that's how it applies to everything. So if we look at the first one then, a, so x squared minus 36, that's represented the same way as this a squared plus b squared. So if you wanted to add another little step in here to help you, that's the same as writing x squared minus 6 squared. And then you can just kind of fill in the gaps. So it's going to be x plus 6, x minus 6. Okay. The second one looks a little bit trickier, but that's just because we don't have a number there. We've got a algebraic thing going on, I guess, term. So 9p squared minus 16q squared. We need to think about the numbers in the front of them as well. So if it's 9, that's made up of 3 times 3, right? If it's 16, it's made up of 4 times 4. So we know we're going to have 3p, 3p, because 3 times 3 is 9, p times p is p squared. And one's got to be positive, one's got to be negative, and that will be 4q. 4q. Now the reason why one's positive and one's negative is because it almost gets rid of the in-between bit. If we simplify this, expand this, we get a squared, firsties, outies, we get minus ab, innies, we get plus ab, lasties, we get minus b squared. If we simplify that, we get a squared plus AB, minus AB plus AB is 0 minus B squared. So that's where that helps us with surds before. Cool. Okay, can you guys have a go at this? Oh no, actually, this last one's tricky. Right, I'm going to show you first. So the 3 is going to come out of the brackets for this one. So have a think about what's going to go in those brackets there. This one's a tricky one. Have a go. Once you've got your answer, pop it in the chat. Has anyone got an answer yet? Cool. So if we take that 3 out of the brackets, then we are going to be left with an x. And if we've taken it out of the 75 as well, we're going to end up with 25. Hang on, let's reword it a little bit. So we've taken the 3 out, we're going to end up with x squared minus 25. That's a bit easier to explain with its y squared still. Then we need to work with that x squared minus 25y squared. So if you weren't sure before, maybe have a think about now how we can put those into 2 brackets using the rule of difference of 2 squares. Cool. So we're going to have an x there and an x there. That makes our x squared. We then need a plus and a minus. Our plus and our minus. Fantastic, SM. You're absolutely right. It's going to be plus 5y minus 5y. And that will get us our 25y squared. Brilliant. Well done, guys. I know that was a bit of a whistle-stop tour on factorizing. Plenty to get your head around. We won't have time to do any exam questions, but I feel like most of you are quite capable of this, and they've been put in the attachment as well. So have a go at those in your own time. I think it'll be really helpful for you. But what we'll do now is have a little bit of a break again. Come back for 1:30, and we'll get going with the last bit on my favorite bit, which is rearranging and solving equations. So I'll see you guys at 1:30. Hello guys, cool. So we have half an hour left of the class today. You've all done really well so far. Last half an hour. So push through, try and answer as much as you can. And we'll be looking at solving equations and rearranging formula. It's my favorite bit. Now, rearranging and solving equations, it's a tricky one because until you've practiced a lot, there's not really too much you can teach. It's just about being able to see what you can do and doing a bit of trial and error. And there's not really a right way of doing it, as long as you were doing mathematically, working out the right numbers. Otherwise you're going to, like, the sums are correct. Some key kind of rules are that when we're solving, we want to end up with x equaling a number or a equaling a number, whatever they tell us. Make sure you do the same to both sides. If you're adding to one side, make sure you add to the other side. If you subtract from one side, you subtract from the other side. Or do the opposites when you cross the equals sign, and we'll come to that. So if something is squared, the opposite side needs to be square rooted. Or if it's multiplied, you need to divide. A few top tips are that the best thing to do is to remove the fractions first by multiplying the bottom. Then the next best thing to do is to get rid of brackets. There's one that kind of contradicts that, but we'll go through that in a minute. So we're going to have a look at a few kind of different tips and tricks and what happens if you get a certain situation. So to start with then, can you guys solve this top one? So number one, 5x plus 4 equals 8x minus 5. So can you solve that one for me? Pop your answers in the chat. I just want to make sure we're all at the same stage, because if this one doesn't make sense, we can go through it, but if it does make sense, we'll move on. Yeah, nice, Eslan. Does anyone else want to pop their answer in the chat? Cool. Okay, brilliant. So we are going to be rearranging it by, let's think about this. We want to get x by itself on one side. So let's move the 5 over. So let's take away 5 on both sides. So we're going to have 4 equals 3x minus 5. Now let's add 5 to both sides. We'll get 9 equals 3x. Divided by 3, we get x to equal 3. I think that one makes sense to most of you. Number 2 is also fairly straightforward. We just need to multiply out the brackets, and then we can do the same thing by rearranging it. The third one, we want to get rid of that fraction. And to get rid of that fraction, we want to multiply everything by 4. The bit where people tend to trip up is when they only multiply one of the things by 4. So if we're multiplying by 4 to get rid of that fraction, everything has to be multiplied by 4. So we need to create a bracket here, because everything inside that bracket needs to be multiplied by 4. Does that make sense? This is where people tend to trip up quite a lot. So it's not just going to be 4 times 4x, because we need to think about that minus 7 still. Yeah. Okay, cool. The fourth one then is we want to get rid of both of the fractions. So we want to kind of do what we call a cross multiplication. So we need to multiply everything by 2 on the other side, and then everything by 3 on the other side. So let's clear all of that. So if we want to multiply everything by 3 first, we need to create brackets because everything has to be multiplied by 3. You can do it without the brackets and just work it out there and then, but this just helps you to work to remember what to do. So everything's being multiplied by 3. Sorry, not the bottom, just the top. And the same on this side. So 2, 4x. What am I doing? Getting rid of that 2 because we're multiplying it by the 2. So 2, 4x plus 10. And that gets rid of our fractions. Then we can just expand out and solve it. Okay, does that make sense to everyone? Yeah, perfect. Okay, now, sometimes we get ones where we need to deal with square numbers. So, dealing with squares. So this time we need to solve this equation to find what x is. Now, we're going to do exactly the same kind of thing. We need to get x by itself. So start with what we can. So let's take away 8 on both sides, and we'll get 72. Now let's divide by 2. So we're getting a bit closer to our x being by itself. If we divide by 2, we get 36. And then if we square root it, we're going to get 6. Now, the important thing to remember here is that, why did I write square root 6? Square root of 36. The important thing to remember is that our answer can be positive or negative 6. Because 6 times 6 is 36. But so is minus 6 times minus 6. Remember, 2 negatives cancel out to be a positive. So we always need to make sure we write our answer as plus minus 6. So it's a positive or negative 6. A question might say, like, if it's in terms of like people being the answer, obviously you can't have a negative number of people. So there'd only be one answer. But in this case, it has to be positive or negative. Okay? Does that make sense to everyone? Cool. So that's how to deal with square numbers or squared x. Another different type of thing is when the subject appears in the fraction. So this time we want to make b the subject of the formula. So how are we going to do that? Well, we need to remove any of the fractions first, then collect all of the like terms on one side, and then we need to divide by what we call the integer. So let's have a think. Most of you will be able to get this without really needing to think about it. So if we want to make b the formula, remember we said our first rule was to get rid of any fractions and then get rid of any brackets. So we need to multiply by 4. So we're going to have 4a equals 5b plus 3. Remember, we're getting b to be the subject of the formula. So let's do 4a take away 3 on this side equals 5b. And then we can do 4a minus 3 all over 5. And that will get us b by itself. Does that make sense? That one's a bit trickier. Cool, fantastic. Right, have a go then at this one. So make v the subject of the formula. So a equals v minus u divided by t. can you make V the subject of the formula? Yeah, well done, Eslam. Really good. You've missed out one of the letters, Lily. We've got A equals V minus. Yeah, well done, Hilal. Fantastic, guys. Really well done. I'm very impressed. Yeah, you're all pretty much right. So we need to multiply by t first to get rid of the fraction. So AT equals V minus U. And then we can just add the U. Easy. AT plus U equals V. Fantastic. Really well done, guys. Cool. Okay, I think there's one more thing that we need to go over before we're going to have a go at some exam questions, because exam questions are the main part of this. Really, you can't really learn how to do it. So this is when the subject appears twice. So make P the subject of the formula. Q equals P plus 1 divided by P minus 1. So you can see here we've got P featuring twice. Now, if something features twice, at some point we need to factorize. Okay, that is key. At some point, we need to put things in brackets. Sounds counterintuitive because we said always like expand the brackets, but if they appear twice, we need to put them into brackets. So firstly, we need to multiply out the fraction, because remember, we don't want any fractions. So we're going to have Q brackets P minus 1 equals P plus 1. Okay. We then want to expand out our brackets. So we'll have PQ minus Q equals P plus 1. Okay. So we've removed the fractions, we've multiplied out the brackets. We then need to collect all the subject terms on one side. So we want all the P's on one side. Yeah. So we're going to have PQ minus Q minus P equals 1. But let's put the Q on the other side because we just want the things including P's. So PQ minus P equals 1 plus Q. Right, so that's collected all the subject terms on one side and all the non-subject terms on the other side. Does everyone understand what I mean by subject and non-subject terms? So the subject terms are the ones including the P, so whatever we're making the subject. So that includes PQ. And the non-subject ones are anything that doesn't include P. Cool. We then need to put our P's into brackets, because what that means is that we end up with only one P. Can you see what I've done there? Does that make sense to everyone? If you don't understand, please do say. But what we've done is we've factorized it so that P is our common term, which stays on the outside, and then on the inside we're left with Q and then minus 1, because when we expand it, minus 1 times P is minus P. And that helps us by leaving us with just one of the subject that we want. Then all we need to do is make a fraction again. So P equals 1 plus Q divided by Q minus 1. Does that make sense to everyone? And that's our answer. Yeah? Please say if it doesn't. Okay, I'm assuming it makes sense to everyone. Brilliant. Right. Can you guys then have a go at this one, please? So pop your answers in the chat when you've done it. So have a little play with how you can get it to be factorized. See if you can manage that. Cool, I've got one answer, fantastic. Looks good to me. We'll go through it in just a second though. Does anyone else want to pop their answers in the chat? It's really helpful so I can see how you're getting on. I'm not sure. That's fine. We're going to go through it. So first, Lily, have a go at getting rid of, I know you weren't there at the start. Can you get rid of the fraction on the bottom? What do we need to do to be able to remove that fraction on the bottom to get it over to the other side? So I'll give you a little head start. So we want to multiply by y minus z to get the what to get rid of our can't speak, our fraction. It's going to look a bit like that. And I'll see if you can go from there. Okay, let's carry on with it then. So we want to expand the bracket. So we get xy minus xz equals y. Then we need to get everything with y on one side and everything without y on the other side. So let's take away y. And then let's add xz. Then we need to put it back into brackets so we end up with only one y. So y brackets x minus 1 equals xz. Then we just need to divide by x minus 1. So xz over x minus 1. Does that make sense to everyone? Lily, does that make a little bit more sense now? I know you weren't there at the start. Yeah, cool. Watch back through the other example that we did if you're not sure. And that might help a little bit more. Brilliant. Well done, guys. Okay. Now we're just going to finish with a lot of exam questions because this is the main bit that you're going to get all the practice with. So this is a 5-mark question. So quite a lot of marks really. Work out the length of each side of the given square. So they want you to basically work out what x is and use that to work out the actual length in a number rather than as a formula or as an equation. Okay, so work out the length of each side of the given square is a key word here as well. So have a go at this question. It's quite a tricky one to start with. So think about what the lengths of the sides of the square will be. And how will that help you? Okay, so we know that, oh, fantastic, Esther. Amazing. Yeah, cool. So we'll go through it for everyone else. So the sides of the square are all going to be the same. So we know that this side here equals this side here equals this side here equals this side here. So that must mean that 5x minus 20 must equal 4 brackets x minus 2, because they are the same length as it's a square. Now we just need to rearrange to be able to find out what x is. So remember we said you want to get rid of the brackets first. So let's expand that. And we can fill in the gaps on the other side. Now we want to try and get all the x's, anything including an x, on one side. So let's add 20 to the other side first. And we're going to get plus 16. Are we going to get plus 16? No, we're going to get plus 12. And then on the other side, we're going to take 4 away from 5, we'll get x. So x equals 12. Now, that must mean that the length of a square, we can pick either one. Let's pick this one. If x is 12, we need to do 5 times 12 minus 20. Now, 5 times 12 is, oh gosh, 60. 60, take away 20 is 40. So each length of the square must be 40 centimeters. Does that make sense to everyone? Does anyone have any questions about it at all? No? Cool. Okay, perfect. Right, I wanted to show you one more question because, what was it? This one. Okay, so either have a go at number 10, which is slightly easier, or number 15, which is slightly harder. And we'll go through both of those. I mean, they're both still pretty difficult. If you've got an answer, pop it in the chat. Cool. Okay, we'll just go through the second one because it's slightly harder. So rearrange the formula to make A the subject. Okay, the first thing we want to think about then is probably keeping the A on one side and trying to move everything else to the other side. So let's take away UT first. There's not really a right or wrong way of doing this, to be honest. AT squared. Now the next thing we want to probably do is divide everything by a half, or multiply by 2 to get rid of the fraction. So multiply everything by 2 makes it slightly easier. So S minus UT equals AT squared. Then all we need to do to get A by itself is to divide everything by T squared. So 2 brackets S minus UT over T squared equals A. And that is everything. Does that make sense to everyone? Yes. Brilliant. Well done, SM. I just saw your answer. That's fantastic. Well done, guys. It's been a long one today, and you've all done so well. It has really been a very, very full on. So you've all done really well. I've put a link in the chat if you want to give some feedback about the session. So if you think there's anything that you think we can improve on, please do let us know, because the company are working very hard to try and make things better for you guys, or if there's things that you like to keep them in the following sessions, and what you find helpful and what you don't find helpful. It's really useful. So if you could fill in that survey, that would be great. It will literally take you 5 minutes. So what you like and what you don't like. And apart from that, that's pretty much everything. If you've got, I'm just going to stop recording.